Hello everyone, today we will learn about threading in RxJava 3. If you want to fully utilize RxJava potential and potential of the hardware on which your programs run, you need to be familiar with this concept. And today we'll answer few important questions. Let's get started. Do you always need to care about threading when using RxJava 3? Of course not, but if you perform some heavy tasks like reading from disk, processing images, etc., you should always use RxJava threading mechanism. So, how to perform such heavy computation with the help of RxJava? First thing to understand is that whenever you see such code without any so-called threading operators, this code will be performed on thread which created observer and subscribe to it. Usually, it will be the main thread of your application. You can see according to the name of this method that this piece of code reads something from disk. And now suppose it takes a lot of time, for example 10 seconds. If we have some UI in our application, it means that when the user clicks some button, it will not get invoked until reading from disk finishes, which is of course bad. Basically, we are blocked for 10 seconds and we can do nothing. So how we can in our example read something from disk and not block main thread so our UI stays responsive? Well, it is basically by applying subscribe on operator. Subscribe on tells the observable to emit items on a separate thread. In our case, our observable basically emits action which is read data from disk. To subscribe on, we need to pass scheduler, and scheduler basically indicates what threading mechanism we want to use. And for such a thing like reading data from disk or making requests to some web API, whatever, it is recommended to use schedulers.io. And now, at this point, the summary is that whenever you need to perform long-running operation, use subscribe on. That way, the job will be done on the background thread, leaving your main thread free and responsive. Now let's discuss few important information about the subscribe on. First of all, it can be put anywhere in the stream declarations. For example, if you have 10 different operators in your stream like filter, skip, take, whatever, you can put subscribe on in any place and it will still work fine. Secondly, there are some factory methods which applies default scheduler on observable. So actually using your own subscribe on operator in such a stream doesn't have any sense. For example, observable.interval internally under the hood uses scheduler.computation, and scheduler.computation is basically different type of schedulers. We already discussed scheduler.io, and scheduler.computation is different type of schedulers. We'll discuss this very shortly in more details. So as I said, actually in such a case, applying your subscribe on operator with your own scheduler doesn't have any sense, because under the hood some other scheduler is already used and applied. And if you set multiple subscribe on in the churn declaration for whatever reason, the top must win. So the one which is declared the closest observable keyword. Alright, without only throwing theory on you, let's check practical example of subscribe on. So I have very simple observable just stream which emits 5 items, 5 integers. On next, I'm printing the thread name which pushes items down the stream. And in the subscribe, I also printing the current thread name. So basically I'm printing the thread name for my observer here. And also this piece of code, we will discuss this shortly. Let's run this example without actually subscribe on applied. Okay, as you can see, everything is pushed and received on the main thread, right? So our method start, main thread started, and main thread processed all the items, pushed all the items, and also received all the items. Now let's basically add subscribe on, and we'll use schedulers.computation. And as I said, we'll discuss schedulers shortly, but for now, let's skip this. Let's see what happens when I run this. As you can see, there is no longer main thread used. Everything is on the different thread, and actually you see Rx computation thread pool -1 thread. And schedulers, that computation is actually pool of thread. So we are using one of the thread from the pool. And no longer our main thread is occupied and is free. Now, I was talking about this piece of code. Let's comment this out. And the purpose of this piece of code is basically to prevent main thread of this console application to finish. So when I have this commented out and I run this example, we see exactly nothing. Our main thread executes and finishes right away without waiting for our background thread to finish. So why is that? Well, when we encounter this line, when the main thread encounters this line, it switches the thread for this piece of code and leave it as it is. So at this point, our main thread is free, so it basically can leave this piece of code, and further, it leaves our main method, actually causing our application to be finished. And why this happens? Of course, the main thread, as the name suggests, is the main thread of the application. So whatever the main thread finishes, whenever the main thread finishes, any other thread is also finished and the process is finished. Before this video ends, let's discuss different type of scheduler. And first of all, we have schedulers at computation, and it is intended to use for some heavy calculations like complex algorithms, processing images, and all other related stuff. And how schedulers at computation works is under the hood, it basically maintains pool of threads. So whenever you want to use this scheduler, some thread from that pool is fetched out and used. And the number of this thread is basically determines of core of CPUs your computer has. Then we have schedulers IO, and I already discussed that. It is intended to use for reading, writing from disk, or network requests, so basically stuff related to input and output. And similarly to scheduler computation, under the hood it maintains pool of threads. However, this pool of threads can grow or shrink depending on the amount of tasks that this scheduler needs to handle. When it comes to schedulers, that new thread, it basically works that way that for any new observer of some observable, new thread will be created. So under the hood, there is no any thread pool, and by using this, we can save some resources. And this one shouldn't be rather used for very heavy operations, very heavy calculations. And lastly, we have schedulers.single, and it is intended to use when all items which are emitted by some observable should be processed sequentially, one by one on a worker thread. So it doesn't have any thread pool like schedulers.computation or schedulers.io. This is basically a single worker thread, and this single worker thread does all the work. There is also schedulers.trampoline. However, I don't want to discuss this because it is rather rarely used. If you want to know more about this, basically check on the internet. Alright, we reached end of the video. However, there are still some important topics to describe when it comes to threading in RxJava 3, and it will be discussed in the next video. For now, thank you for watching. Have a good day.